So now we're going to do Chapter 7, Section 2, which I referred to a lot in the last section. And now you're going to be doing all those things you did in the last section, but you're going to understand now why you did them and why I said it was going to be a little bit easier moving forward. So when we look here, again, remember that we have our fundamental trig identities on the left there. And like I told you, or have mentioned multiple times, obviously these reciprocal identities are supercritical. These Pythagorean identities are supercritical. The even and odd and the other ones, we're going to get to those eventually, but we're really focusing on the first two, okay? So tips for verifying, and I'm going to show you as we go, but the first tip is to always work on the more complicated side. You're going to understand what I mean after. Factor if needed. Again, we learned how to factor expressions in the last section. Break it down to terms of sine and cosine whenever possible. That's probably the easiest way to break it down. So that should be your go-to when you don't know what else to do. And then, of course, use your Pythagorean identities. So let's go and I'll show you. So when you get to this page, we're going to get to these examples. We're going to look to the more complicated side. In both of these, the more complicated side is the left. It can be the right side. That's okay. But in this one, it definitely was the left. When I get here, I'm going to kind of try to break this down, and I'm going to try to think about any potential Pythagorean identities or anything that I might have learned that might help me as well. And I did learn some things about secant squared and tangent squared and all that, but I think I'm going to do something even more basic. If I look at this and I see an expression at the top and it's over a single denominator, I can break it down, and I can actually break this down to secant squared x over secant squared x minus, for this sign, 1 over secant squared x. Well, this is 1, and 1 over secant squared x is equal to cosine squared x, okay? And 1 minus cosine squared x, we all know, is sine squared x. And so I'm able to use that Pythagorean identity here to get to what I needed to get to. When I go to the second one, sort of the same concept, except for I'm looking at, it's the same concept in the sense of I'm looking at Pythagorean identities whenever possible. And I know immediately that my numerator is a Pythagorean identity. So I can do 1 over cosine squared x secant squared x. At this point, again, I know there's some identities that have cosine squared and secant squared, but I think I'm just going to break this denominator down into sine and cosine. Oftentimes, that's going to be the most helpful. I know secant squared is 1 over cosine squared x. And so notice this cancels and this cancels, leaving me with 1 over 1 or 1. And so I know it matches. So again, start with the more complicated, try to get to the other side. And the beauty of this is that, you know, the other day you were just given this and told simplify, right? That was your instruction, and you didn't have this. So you didn't really know where you were going. Today, the instructions are very different. They're telling you to verify basically that this left side equals this right side. And so this is your guide. This is what you're going to use. And, you know, if you start with the right, then the left side is your guide. But basically, that's going to let you know, hey, I got to somehow get these secants to look like sines. I've got to find a way to get a sine in here so that this kind of matches. And it's very, very helpful. Again, I come over to here, and there's nothing really for me to factor out, so I'm basically going to see how can I convert this, right? So, again, I always have to think sort of, I know my more complicated side is the left side. I'm going to see, right now, I have tangent of x divided by secant of x. Tangent is sine x over cosine x, and that's divided by secant, which is 1 over cosine x. So it's sine x over cosine x times cosine x over 1, cancel, cancel, and I'm left with sine x, which is what we wanted in the first place. And so that's it. So I'm going to try to write it out a little neater here for you guys moving forward. Okay, so when I look at this one, you know, I've got some options here. I know that I could technically distribute sine x squared to this. That's always something I could do. And I know that I might possibly have a Pythagorean identity here. And when I have one of those, I really try to focus on it. So I'm going to go with that. I know that 1 plus cotangent squared theta is the same as cosecant squared theta or x. So it's sine squared x times cosecant squared x, and again it equals 1, right? So I'm going to see how can I simplify this. Well, I know sine squared x is going to stay the same, but cosecant is 1 over sine squared x. And so you're already going to start to see the pattern. These cancel, 1 equals 1, check, we did it. And so again, the combination of Pythagorean identities and using, breaking things down to sine and cosine will usually be enough. So each one that we do, is obviously going to get a little bit more challenging. Now here I have the left side and the right side, and I remember we're always going to kind of try to figure out how can we get from one to the other, how can we make the left side equal the right side or vice versa. I'll be honest with you, in this particular problem, I think the left side is simpler. I think the right side is a little bit more challenging, so I could technically work on the right side if I feel that that is better. So I'm going to try that on this one. I know that secant is 1 over cosine x minus cosine x. So I could, remember how we did in the last section, we can actually subtract these. I can make cosine x my LCD, multiply both sides by cosine x, and I'm going to get 1 minus cosine x squared. And I know that 1 minus cosine x squared is cosine squared x, is sine squared x over cosine of x. And notice that I made these two equal to each other. So I worked on the right side, and I found that that was a little bit easier for me, okay, in this particular problem. Now, if you just want to make a pattern and always start with the left, I mean, I know that you could do that. I don't suggest it. I think you should always look at the one that's a little bit more complicated and start with that one. But let's say we wanted to go from the left side. I would think of sine squared x as 1 minus cosine squared x over cosine of x. And then here, when I have a single denominator and an expression at the top, that's 1 over cosine x minus cosine squared x over cosine of x. 1 over cosine x is secant of x, and this would just be cosine of x, because I would simplify those. And so again, I could work with the left side and make it equal to the right. So it worked either way, okay? So you can do it where you always, kind of like make the left side match the right side. And if that doesn't work, then you could try to make the right side match the left side. So for this one, I feel, for the purple one, number 6, I do feel that it's probably better to work with the right side, but I'm going to do the left side first, okay, just to kind of follow that pattern. And so I'm going to see this as 1 over, I'm going to take the secant and make it 1 over the cosine of x minus the sine of x over the cosine of x. So I'm going to consolidate that denominator. It's going to be 1 minus sine x over cosine x. And when I do state change flip, like I do 1 divided by that, it's really 1 times cosine over 1 minus sine. It's going to be cosine of x over 1 minus sine of x. And when I get here, I kind of get stuck. However, one thing that I can think of is multiplying, which we learned in the previous section. How about if I try to multiply top and bottom by 1 plus sine of x? What that's going to do, what you're going to notice, is at the top, I'm going to have cosine of x times 1 plus sine of x. And at the bottom, I'm going to have 1 minus 1 squared. Really, I'm going to FOIL it, right? It's going to end up being 1 minus sine squared of x. And so, again, if I keep going here, I know that that's going to be cosine of x. And I'm actually going to distribute this plus cosine of x sine x all over, and 1 minus sine squared x is cosine squared x. Now because I got my denominator to one term, I'm going to make it cosine of x over cosine squared x plus cosine of x sine of x over cosine squared x. I kind of separated it. And this left one, I'm going to simplify. I'm going to get 1 over cosine x. This right side, I'm going to simplify this, and I'm going to get sine of x over cosine x. And my last step, this is secant x plus tangent x. And finally, I got to the right side, okay, which was this. So that was a lot of steps, I will say, but we did get there, right? It was very complicated, though. That one was complex. That one required you to break the denominator into sines and cosines. Then it required you to multiply by the conjugates to get there. So it certainly was a process. Again, if you remember all the strategies we taught you in the previous section in 11.1, go back and look at those, or sorry, 7.1. You want to go back and look at those and constantly ask yourself, okay, do I know how to, when should I factor? What would factoring look like? What would a GCF look like? What would foiling these look like? What would conjugates look like? Because those are, how do I add and subtract these rational expressions with tangent and cotangent and sines and things like that? So practice that, because all of those are going to be very helpful here as you go. Now, obviously, when I look at this problem, the right side looks much more complex than the left side. And so I'm going to work with the right side on this one here. Okay, so when I get to number 7, I start and I notice that we're adding these denominators. Well, I know when I add, I have to multiply by my least common denominator, which is going to be 1 minus sine x and 1 plus sine x. Obviously, I'm going to multiply the numerator by the one missing in the denominator, and my answer, my denominator of my answer, my sum, will obviously include this denominator of 1 minus sine x and 1 plus sine x. So again, when I multiply here the minuses, and I get 1 times 1 plus sine x as my numerator, plus this cancels, so plus times 1 minus sine x. So when I do this, I have 1 plus sine x here, plus 1 minus sine x here, all over, and if I FOIL that, it's 1 minus sine squared x. So again, this numerator becomes 1 plus 1 is 2, plus sine x minus sine x are going to cancel, so it's 2 over 1 minus sine squared x. I know that 1 minus sine squared x is cosine squared x. So 2 over cosine squared x is the same as, think of it as 1 over cosine squared x times 2. And 1 over cosine squared x is equal to secant squared x. So secant squared x times 2, or 2 secant squared x, like this. And so we managed to get there. So again, when you get comfortable, I promise the more you do, the better you're going to get at this. Again, we keep going. We have more and more examples. Obviously, some look more difficult than others. 8 is going to be very similar to what we just did. I'm going to multiply by the LCD, which in this case is 1 minus cosine x, 1 plus cosine x. So again, I'm going to multiply the top by the one that's not included. So it's going to be 1 plus cosine of x. And I'll multiply this one by 1 minus cosine of x. So 1 plus cosine x plus 1 minus cosine x. My numerator, my cosine x's will cancel, and 1 plus 1 is 2. My denominator will be 1 minus cosine squared x. I know that this is sine squared x, and just like we did the last time, it'll be 2 times 1 over sine squared x, which is 2 times cosecant squared x. So 2 times cosecant squared x is where we're at. For number 9, we keep going. We've got tangent squared x plus 1, cosine squared x minus 1, and it equals negative tangent squared of x. So again, when I look at these, I mean, I could think about foiling these out. I could maybe break this tangent into sine and cosine, but I'm going to be thinking more along the lines of my Pythagorean identities, as should you. Because when I see tangent squared plus 1, I know that's equal to secant squared x. And cosine squared x minus 1, I know is equal to negative sine squared x. And if you're asking me where these go or where these come from, well, I know the first one is a Pythagorean identity. It's tangent squared x plus 1 equals secant squared x. That one was easy. The other one is sine squared x plus cosine squared x equals 1. So if I move the 1 over here to get cosine squared x minus 1, I know I'm going to have to subtract sine squared x from this side to get it to the other, and that's how I get that, okay? And so again, once I'm at this point, now what I can think of in terms of is sine and cosine. So secant squared x is 1 over cosine squared x times, right, minus sine squared x. That equals minus sine squared x over cosine squared x, and that's going to equal negative tangent squared x. And so that's how I prove that left side equals that right side. Anytime I see something squared, I know I'm thinking of those Pythagorean identities, okay? And so when I see secant squared minus 1, it takes me back again to this one. And I know that secant squared minus 1 is equal to tangent squared of x. I know sine squared x minus 1, similar to what I did before. I know that's going to be minus cosine squared x. And so when I put those two together, I have to now kind of keep going, right? So I know this is sine squared x over cosine squared x times negative cosine squared x. These cancel, leaving me with minus sine squared x, which is, again, what they wanted. Again, here, this one's a little bit more basic. Here I have tangent times cosecant equals secant. So obviously, if secant's only one factor, that looks like the simpler one, so I'm going to work on the left. I know tangent is sine x over cosine x. I know cosecant is 1 over sine of x. So that simplifies. It gives me 1 over cosine x, and 1 over cosine x is secant of x. And so, again, I know that I'm proving it. And so like we talked about, it just gets easier and easier because you know what you're shooting for. You know when you start, you know where you're trying to get to. And in 7-1, you didn't know that. In 7-1, all you had was one side, and you weren't really sure when you were done. Having the other side is super helpful because it serves your guide. You know exactly what you need to do to get there. Okay, so we keep going, and we're going to go to here. Tangent plus cotangent equals secant times cosecant. So I don't know which one looks simpler or not. I'll just do the left side. I know the left side is sine x over cosine x for tangent. And cotangent, I know, is cosine x over sine x. So if I'm adding these, I know my LCD here has to be cosine x times sine x. And I have to multiply both sides, you know, both numerators by that. So when I multiply this numerator by it, I get sine squared of x. And when I do the exact same thing here, right, sine of x, cosine x, I know that I'm going to get plus cosine squared of x. And so when I keep going, I know this is going to be 1 over cosine of x, sine of x. And so at first glance, I think, man, I might not be done here. But if I think about it, I know that this is the same as 1 over cosine of x times 1 over sine of x. Think about that. If I multiply these together, I get 1. If I multiply these together, I get this. So that works. And if that works, I know 1 over cosine x is secant x, and 1 over sine x is cosine x. Not cosine, cosecant x. Cosecant x. And that's how we get to that. So that one was a little bit tricky. I mean, I kind of did great, and I knew what I was doing to here, and then I kind of had to take a second look at it and realize I could break that down into two factors and then go to secant and cosecant. I'm going to do something similar over here. I know cotangent is cosine x over sine x, and I know secant is 1 over cosine x. These are going to simplify. I'm going to be left with 1 over sine x, which I know is cosecant of x. And again, it matches. So that one was much, much easier. I come over to this one, and again, I see the left and the right. They both have, you know, their little challenges, but I'm going to just keep going, focusing on that left side. And so I'm going to break this down first over 1 over sine of x minus the sine of x, technically over 1. I know that if I do subtract those, I make my denominator sine of x. I have to multiply both sides by that. When I multiply the first side, I'm just going to have 1. When I multiply the second one, I'm going to have sine squared x. I know that 1 minus sine squared x is cosine squared x over sine of x. And at first, that seems a little bit confusing. However, I know that I can think of this as cosine of x over 1 times cosine of x over sine of x. Notice that if I multiply cosine and cosine, I get the numerator. And if I multiply 1 times sine of x, I get the denominator. But by doing this, look what happens. This first term, cosine of x over 1, is just cosine x. And this second one, cosine over sine, is cotangent of x. And together, we get there. Okay, so again, if you work with the left side, you're going to get there. If you work with the right side, you'll get there. I think either one of these two sides would have been manageable to have done. Which one's easier? I mean, that's kind of up to you to decide. You know, if we kind of look at the right side and we did that one first, this would be cosine of x, and this is cosine of x over sine of x. So together, this is cosine squared x over sine of x. Let's see what else I could have done. I could have converted that to 1 minus sine squared of x all over sine of x. And then I could have separated those out. So it would have been 1 over sine of x minus sine squared of x over sine of x. And when I did that, 1 over sine of x is the cosecant of x, minus, and when I simplified these, I would have got sine of x, and I would have gotten the answer as well. So something tells me that right side would have been the better one this time. But again, you just got to figure it out and do it. It'll work either way. Again, when I see this right side to this left side, I'm not even sure which one I want to start with. My instinct is to start with the right, but I'm going to start with the left and try that. So secant is 1 over cosine of x. Tangent is sine of x over cosine of x. So it's going to be 1 plus sine of x all over cosine of x. This doesn't really help me too much, but what if I try to do, at this point I'm thinking conjugates, right? So let's do 1 minus sine of x, 1 minus sine of x. Let's see how that breaks down. My numerator will be 1 minus sine squared x, and my denominator is going to be cosine of x times 1 minus sine x. This numerator, 1 minus sine squared of x, I know that's the same as cosine squared x over cosine x 1 minus sine x. So I could break this apart, and I could do, I think I want that. Oh yeah, I can simplify at this point. I have a cosine squared up top and a cosine at the bottom, so these would cancel, and it would leave me with cosine of x over 1 minus sine x. And that's where I needed to end up. So that's if I worked on the left side first. If I had worked on the right side first, I would have started here. And I think what I would have done here is I would have started with the conjugates. I would have started with 1 plus sine x, and I would have done 1 plus sine x here, and I would have multiplied. So it would have been cosine times 1 plus sine x all over 1 minus sine squared x. So this would be cosine 1 plus sine x. This denominator would have ended up being cosine squared x. When I simplified, this would go away. I'd have 1 plus sine x all over cosine of x, 1 over cosine x plus sine over cosine x, secant x plus tangent x. And I believe that's what I started with. So this would have worked out as well. So again, guys, I just constantly reiterating that you can work with either one. Try to pick the one that looks the most complex. Sometimes it's hard to tell. So on this one, these are going to get more and more complex. I don't even know which side to start with, but I'm going to start with the left side because I'm sort of seeing a pattern here. I know that there's a Pythagorean identity that deals with cotangent squared, and it basically says that cotangent squared x plus 1 equals cosecant squared x. And so I'm going to play on that a little bit, and I know that cotangent squared x is going to equal cosecant squared x minus 1. So I'm going to substitute this for cosecant squared x minus 1. And then I'm going to think to myself about how I can get this broken down into signs. And I see a lot of cosecants here. And so I know that cosecant is 1 over sine. So I should be able to do some stuff with this, okay? So basically, I know that at the top, I have this cosecant squared x minus 1, but at the bottom, I have 1 plus cosecant. Notice the cosecant's not squared. And I'm thinking that I can factor that top fraction. I know that that's a difference of squares. We haven't seen that today, but I know that that's, or at least I haven't paid attention and seen it today, cosecant minus 1, or cosecant of x, right? So cosecant of x minus 1 times cosecant of x plus 1. That would be my numerator. My denominator would be 1 plus cosecant of x. And I know that this and this are the same. 1 plus or cosecant plus is the same thing. And so that's going to leave me with just cosecant of x minus 1. At this point, cosecant is 1 over sine of x minus 1. And I know that if I was to actually do the math here and make sine of x my LCD, it would be 1 minus sine of x. And so that is exactly what they wanted here. How did I get that? I did sine of x, multiplied those, right? Made my LCD, and these canceled, leaving me with 1 and whatever. So you see how I did it. So that one was a little bit tricky. I think there's going to be a couple more sort of like that. Again, I know tangent squared x plus 1 equals secant squared, so I'm going to kind of go with that same concept. I know this is going to be secant squared minus 1, or secant squared x minus 1 over 1 plus secant of x. I'm going to factor the top, secant of x minus 1, secant of x plus 1, all over 1 plus secant of x. So I know that these will cancel. It's going to leave me with secant of x minus 1. Again, secant is going to be 1 over cosine x minus 1. And when I do the math, again, LCD is cosine of x. So cosine of x will be my denominator. It'll be 1 minus cosine of x. And so it looks like that. And so the patterns will repeat themselves, and the more you do, the better you're going to get at seeing these patterns. Last couple. This one looks kind of challenging. The tangent 4 of x. I got all these things. I'm going to look, and I'm going to do this right side. It appears to me I can factor out a tangent squared of x. That's going to leave me with secant squared x minus 1. I know that secant squared x minus 1 is one of the Pythagorean identities, and it equals tangent squared of x. And together, this is tangent 4th power of x. and I did it. So that one's kind of easy. Factoring out the GCFs is great. I love doing those. When I look at this one over here, this is a lot going on here. I'm not really even sure where to begin this problem. But when I look at the right side, it looks like the most complex. And I'm just going to kind of go with what I see here. I look at this cosecant squared x, that's fine. I look at this parentheses and I feel like I can pull out a cotangent. And that's going to leave me with 1 plus cotangent squared of x. Now, I know 1 plus cotangent squared of x is one of my identities. I know the cotangent squared of x plus 1 equals cosecant squared x. So I know that this is going to stay the same, cosecant squared x, cotangent of x, but this is going to replace with cosecant squared x, again, because it's one of my identities. And then when I put them together, I see that I have, this is going to be cosecant to the 4th of x times cotangent of x. And we got to there. Definitely easier starting on the right side there. So again, a lot of things for you to look at. A lot of skills, but if you notice in all of these, we did the same things every time. We looked for, first of all, we break down to sine and cosine whenever possible. We look to see if we can factor a GCF, or we look for difference of squares. We did those, right? We did that. We looked to see about conjugates. That was another thing we did. And we did basic adding and subtraction, right, of these using LCDs and things like that. And so any one of these things, you know, the constant things you're thinking about when you get to these. You start with the most complicated, go to the easiest. Keep practicing these, because I promise you the more you do, the better you're going to get.